Welcome and hello. This is a support video in MODSIM, and I'm titling this video Finding Missing Flow. This is a problem of mass balance. When you run a model and you check it, you may be a little confused with where all the flow is going. We're going to go ahead and do a check in this video on a working model. All right, so one of my viewers wrote me in with this specific model and had a question, and that is how to justify or how to check all the flow in all of these demands and where is the missing 10 units of water coming from. I say that because the cumulative flow or the sum of the demands right here are all met. However, it is 10 units of water more than that is released from this reservoir and that is from coming upstream. So where is that extra flow coming from? So let's go ahead and first analyze what we have in our model. To keep things simple, I'm going to only look at the first time period. I'm going to start by looking at the release from this reservoir like here and just do a right click on the downstream link, open up the graph, and then let's move this over here. For the flow, that's correct. I'm going to click on the data tab and then expand right here. The first time period, the first month of the simulation, we have a release from that reservoir of 3687. So that's the flow rate. The units are in 1,000 meters per month. So don't worry about that. I'll just call them units of water. But yeah, 3687. So what I'm going to do is bust open an Excel file and just call this 3687 to keep track of the flows for just the first time period. All right, here are our 4 demands, and these are the links that so not node, but link. There we go. And then they all start at non-storage node NS4, and then they go to either the agricultural, demand, urban 2, or flow through 2 nodes, which are right here listed: agricultural, industry, urban 2, and flow through 2. All right, so again, just focusing in on that first time period, the first month. To make it a little quicker, I'm going to toggle on the graphing mode and then just click on these 4 links so that we can double check the numbers. So just a single left click to select, I'm going to minimize, single left click to the industry, single left click to the urban 2 demand, and then finally the flow through 2 demand. I'm going to open up the results table here and then click on the data tab, expand. Let's take a look at agricultural first right here. The total flow is 800 units of water. So I'm going to type that in over here on the demand side. Let's go back to close that. And then industrial 2258, back to Excel 2258. All right, back to MODSIM, close that. And then here is the demand of urban 2, 339. Open up Excel, 339. Finally, the flow through 2 demand. Let's go back and check that out. We have 300 units of water. All right, so let's go to Excel, type in 300. Now down here, I'm going to total up those 4 demand flows, and we have a total of 3697, which is 10 units of water more than is released from our reservoir here, dam out 1. So where is this extra 10 units of water coming from? Let's take another look at our network. Let's take a look at the flow through this link here, dam out 1 NS2. I'm going to go ahead and click on that. I'll also click on this link here, which is NS5. Yeah, NS5 to NS2, and then downstream between NS2 and NS4. All right, let's take a look at the flow rates. Again, just focusing in on that first time period. So I'll click on the data tab, expand, and dam out 1 to NS2, 3687. That makes sense. That's the same amount as the flow. So I've added a few more labels here. 3687, the same as the reservoir release. Let's see what we get through these 2 links. So NS5 to NS2, this flow entering right here. I'll collapse that. NS5 to NS2. There's a flow of 0 coming in here. Okay, I can remember that. Let me just check the last link here, which is NS2 to NS4. That is 3697. Okay, so we've identified that NS2 is getting a 10 extra units of water somewhere because this was 0 and then this was, 3697. So these 3 links right here are the 2 entering NS2 and then the 1 link leaving NS2. We know that NS2 is somehow receiving 10 extra units of flow for that first month. So let's go ahead and take a look at our model again. And this may not be obvious to anyone who hasn't looked at the model in more in depth, but the very upstream end is this NS1 provides some inflow. There's also a reservoir here and two other demands. Now, what I noticed from this demand flow through one is that if I look at the properties, then on the very first month, we see a flow rate of 10. This is an in-stream flow demand. And if I click on general, it has a sufficiently low priority number, hence a high priority. And if I click on flow through, we see that the receiving node is NS2. So we could double check that that demand flow through one is actually satisfied by clicking on data and then clicking on the plus symbol, flow through one. It is satisfied. The service flow is 10 units of water or 10,000 meters cubed per month. That's where that flow rate is being received. The extra 10 units of water is coming from the flow through demand. That could be deceiving because we actually clicked on this link here, which was NS5 to NS2, and the flow rate reported as 0. However, in the user's manual, this is how in-stream flow demands are discussed and how they're utilized. I'm on page 51 of the PDF file, and if you scroll down, the actual page number on the file page itself says 47. But anyway, this is where we learn about in-stream flow demands. And I think the diagram on the next, here we go, this figure 13 helps us visualize what's happening here. The flow from 2 to 3 through this solid line, this is the actual link that you may see on the page. You can liken this as the link from NS5 to NS2. It had 0 flow, but the 10 units of flow that was coming from this in-stream flow demand flow through was actually going through an artificial link to an artificial node in the same period and delivered to that NS2 node in the same time period to satisfy our mass balance, because non-storage nodes cannot store water, so the inflow equals the outflow at every time period. All right. Well, I hope that was helpful with regard to identifying where was the missing flow. Not necessarily obvious unless you build the model or you look through the model thoroughly to find out where the water is coming from and where it's going.